Now I'm going to discuss about the magnetism. What is magnetism? Magnetism is a special property that exists in particular set of materials. In the early ages, people observed that some rocks used to attract some other rocks. So there is a force of attraction between these two rocks, and these type of rocks were found mostly in the area called magnesia, which is the term magnetism came from. And the property of magnetism exist in this type of materials. So these materials are called magnets and that property is called magnetism. Now consider this magnet. Every magnet contains two poles, one south pole and one north pole. And how can we say that this is south pole and this is north pole? And we'll see it in our future classes. And suppose if I break the magnet into two pieces, suppose just I'll cut the magnet into two pieces, and is it possible for me to get an individual south pole and individual north pole? No, it's not possible. It's not possible because when I cut the magnet into two pieces, and the two pieces which I got by cutting, they themselves act as an individual magnet. Consider this figure. And I took one magnet and I have cut it into two pieces, and the two pieces, that is the two individual pieces which I got, are itself two magnets, that is which contain both north pole and south pole. That means what can we infer from this is magnets will never exist in monopoles. Magnet will always exist in dipoles. Now we discuss about an important thing called magnetic lines of force. What are magnetic lines of force? When I consider a magnet, that is suppose a particular type of magnet is considered, then there exists a magnetic field around this magnet. And this visual representation of the magnetic field around the magnet is called magnetic lines of force. These lines are called magnetic lines of force. And what do they infer is the direction of the magnetic field that is acting at that particular point. That is, if I think this point and the magnetic lines of force are in this direction, that means the magnet field is acting in this direction. And if you consider this part of area, magnetic lines are very dense. It represents the magnetic field is more intense here than the magnetic field around here. Obviously, if the distance is less, the field will be more. The magnetic lines of force are closed loops. They don't have source and they don't have a sink. See this. Now if you observe this figure, what we infer from this is magnetic lines of force are coming from the north pole and they are going into the south pole. So we just say that the source is the north pole and the sink is the south pole, but it's not correct because they exist in closed loops. Suppose consider this particular part of line of force, and it ended in the south pole, and inside this will be in this direction. That is, they exist always in the closed loop. When a thing is in the closed loop, we can't say that this is source and this is sink. If you observe this field, it means the source is south pole and the sink is north pole. So there won't be any source and any sink for magnetic lines of force. And do you know earth is a magnet? That is, earth is having the property of magnetism. By using this particular property of the magnetism, we have invented a device called magnetic compass, which sailors will use in order to find the direction of their sailing. Suppose this is a magnetic material. Okay, this is a magnetic material, and we call this the needle of the compass. That is, the compass will be round like this. Device will be like this, and the center there will be a needle. This needle which I have magnified here is this. And if I say this is the north pole of the magnet, that is, this needle itself is a magnet, and this is the south pole. And consider the earth. Suppose this is the earth and this is geographical north. I'm stressing the word geographical north, and this is geographical south. When I place this needle, it will orient along the direction of the north. But how is it possible? We have said that the north and north pole will repel each other. And how come it is getting oriented in the north direction? Because this is not the magnetic north. This is geographic north. And the magnetic south pole will be here and magnetic north pole will be here. That is, the north pole of the magnet is showing the magnetic south, which is our geographical north. Thank you. And if you like the video, please subscribe.